Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Thoriq Alfarizi and my student number is 2206055265. And this time I will answer one of the questions from the quiz, which is number 2. Consider a problem in engineering that is required to solve using numerical methods. And we need to use DAI5 to deal or solve this problem. Okay, so I have a problem which is solving a system of linear equations using the Gauss-Seidel method. And given solve the following system of linear equations using the Gauss-Seidel method: 3x plus y minus z equals 1, 2x minus 8y plus z equals minus 2, and finally minus x plus y plus 4z equals 3, with an initial guess of x equals 0, y equals 0, and z equals 0, and tolerance of 10 to the power of minus 5. And the solutions using the DAI5 method, which is first intentions. So the main goal is find the values of x, y, and z that satisfy the given system of equations. And the criteria of the intention is the solution should converge of a tolerance of 10 to the power of minus 5. And another intention, which is our main intention, is to solve this problem for the sake of God. So we have our intention, and let's go to initial thinking. So we have three steps of initial thinking, which is problem identification, preliminary analysis, and method selection, like I mentioned in the previous video. So problem identification. So the problem is a system of linear equations suitable for iterative methods like Gauss-Seidel. And the preliminary analysis is ensure the matrix is diagonally dominant or can be rearranged to be so, which is aids convergence. And finally, the method selection. So we need to choose the Gauss-Seidel method for its iterative nature and ease of implementation. And third step is idealization. So we have three steps in this idealization: assumptions, modeling, and approximations. So assumptions is we need to assume the initial guess is reasonably close to the solution, and the model is to rearrange equations for iterative updates. So in this case, x to the power of k plus 1 equals 1 over 3, 1 minus y to the power of k, and plus z to the power of k. The second one is y to the power of k plus 1 equals 1 over minus 8, and minus 2x to the power of k plus 1 plus z to the power of k. And the third one is z to the power of k plus 1 equals 1 over 4, 3 plus x to the power of k plus 1 minus y to the power of k plus 1. And we have our approximation, which is iteratively updates values until changes are within tolerance. And okay, the final one is instructions. So we have three steps in instructions, which is algorithm development, implementation, and execution and verification. Okay, algorithm development, we have to develop the Gauss-Seidel iteration and the implementation. So the implementation here, I use the Python code, and we need to definite the Gauss-Seidel and the A, B, x0, the tolerance, and the max iteration, which is 100, and the n and the x. And finally, we have the matrix, and also this is the matrix, and we have our, if we run this code, we will have our Gauss-Seidel. And here we're going to print the solution. And finally, the execution and verification. So we have to run the code and verify that the solution converges within the specified tolerance. And I wrote an example output here. So the solution is x equals 0.2273, y equals 0.2006, and z equals 0.7548. And this approach ensures a systematic and precise solutions to the numerical methods problem using the Gauss-Seidel method. So we have our example code here, and we're going to run it. So it has run and it prints our solution, which is x equals 0.4313 and so on, y equals 0.4509 and so on, and z equals 0.7509 and so on. So I'm going to copy this solution to the document here. And this is our final solution of the problem using the DAI5 problem solving method in numerical methods. So that's it. I hope you enjoy it, and I will see you next time. Assalamualaikum warahmatullahi wabarakatuh.